All right, can y'all hear me and can you see my screen? Okay, so today I'm going to break this out into 3 different sections. So right now I'm doing the horizontal curve review. Once I finish with that, I'll go ahead and log out of this one, and then I'll go to the vertical curve, which it doesn't open up till 12:30. I didn't want anybody to accidentally get in that room and I'm not in there. And then I'll do the final one with this earthwork. And remember to do your earthwork test that's in Blackboard. I just made an announcement for it, but so if you didn't quite get everything the first time, maybe after the review day, things will make more sense. I only had one person that's completed it, but I told you to go ahead and like make a copy of it. Go ahead and go in there and make a copy of it while you're doing your homework. So you can go in and copy this or print it. So this is online. You can print it. You don't have to come out. You can save it, resume it later. Your answers are automatically saved. So I'm going to go ahead and close it. And make sure I'm not jumping out of this accidentally. I'll check them tonight. I'll try to check them tonight. I'll look over them real quick tonight, your homework. I had a busy day yesterday. I had to do professional development for our division all afternoon and an open house last night, and then I had something else to do, so it was a late day. All right, so I have already saved on my desktop. I've already saved all the problems that I'm going to start working today. So I'm going to first start with horizontal curves. And these are going to be examples like you're going to see on the test. So now this particular one, I mean, you're only going to have, well, I'm hoping that the very most 3 hours to take it. So some of these problems are going to be a little longer today that I'm working. And you will have like a condensed version. So if one's the vertical curve is like 1,000 feet, I'll probably give you one that's 500. Just to make sure that you can kind of work it, but not be so long that it takes forever to work the problems. All right, so for the horizontal, it's a highway curve. The PI is 64 plus 32.2. I is 24 degrees, 20 minutes, and D is 4 degrees. Compute RT, LC, E, M, and L. Compute the deflection angles and incremental chords to lay out the circular curve at 100-foot stations and include total chords. So I'm going to solve for R first. And I'm going to use equation 24(3) on page 720. And I've got my degree of curve, so I'm going to say R equals and 4 degrees. So this is a nice even one. If I get that, I'm going to get 1432.39. And since there isn't any seconds for this particular one, I could just have divided it by 4. It would actually round up to 40 because I got 0.3975. So I'd say 14. Okay. And now with R, I can solve for T. And I'm going to just go ahead and round it to 2 decimal places. And my I is 24 degrees 20 minutes. And that will get me my T. I'm going to plug that in real quick just to see. You should get roughly like 308.82, I believe. I got 308.82. Okay, so moving on. I'm going to solve for LC. I don't know, I have a blank page right in the middle of there. I'm going to solve for the LC next, which is the long curve. Looks like that. Roughly should get 603.77. So what I'll have you do, it was 7.4, is maybe box in your answer when you're doing your test. Just box in what you get for your answer. All right, E is tangent 24 degrees 20 minutes divided by 4. All right, yep, that's it. So you should get 3291. And then we're going to solve for M. So that'll be E. And these should be relatively close. If you see you're way off, then you probably put something in wrong. So just think they're going to be pretty close, E and M are. All right, so I'm going to check them really quick. Tangent. I didn't get that. I did something wrong. Make sure I got the formula written right. E is tangent I divided by 2. I got it written right. Oh, I forgot the T. T times tangent. Missed one thing. Okay. I forgot to put my T in there. So I had the answer should have been right. I just didn't. I forgot to put the T in there. All right, now I get 3291. And then we're going to plug that in to solve for M. Plug that in and we'll solve for M. All right, so now I'm going to solve for the L. I'm going to use equation 24a. So it'll be L equals 100 times I 24 degrees 20 minutes over 4 degrees, which is my D. You should get 608.33. I want to double check it. Yeah, 608.33. All right, so now we have solved. Get back over to the problem. Now we have solved for, I've got R, T, L, C, E, M, and L. So we've just solved for R, T, L, C, E, M, and L. Now I'm ready to get my PC station, and it'll be your PI minus T, and I'm just going to take the plus out over here. I'm going to say 6432.2, and I'm minus 308.8, and get my PC station. So that would be 61 plus 23.4. And then I'm going to add my L. And my L was 608.33. And my PT would be 67 plus 31.73. So there's my PT, there's my PC, and now I'm ready to set up the chart. All right, so I've got my chart set up. Here's my PC. Then I'm going to go to 62, 63, 64, 65, 66, 67, 67 plus 31.7. That should be those two. I got 7.3 here. That should be 7.3. 7. Make sure I did it right. Just make sure my stations are right again. So 64, 32.2 minus T, which was 308.82. That would give me 38. Oh, I didn't leave. I left the 82 off there. So don't do what I did. Here's my two numbers. Now my chart matches. So I'm going to set my chart up. 61 plus 23, 38. This is your 0 line. That's where the instrument's set up. I need to know what the distance between these two are. And you should get 76.62. So 62 minus 61, 23.38 is 76.2. Then the difference between 62 and 63 is 100. So all of these are 100. And then the last one is 31.71. Now to do deflection increments, I've only got to do this one for the one that's 100, and then the end. So for the first one, and I'm going to use equation 2412, where I'm trying to get the deflection increment. This is your incremental chords. So 76.62 times 4 divided by 200, because our degree of curve is 4. And you want that in degrees, minutes, and seconds. I got 1 degree, 31 minutes, and 56 seconds. Actually, it would round up to 57. I'll write it in. So for all the ones that are 100, that'd be 100 times your D divided by 200. So 200 is the only constant. 100 times 4. Two degrees. Now, this one's great. I didn't have to put the degrees in there because it was only to the nearest degree. You have degrees in seconds. Make sure you put your degrees in seconds. So that would be 2 degrees. So I can go ahead and write this is 1 degrees, 31 minutes, and 56.64 seconds. These are all 2 degrees. And I need to do the last one, which would be 3171. So that would be 31.71 times my D, which is 4, divided by 200. I spent an hour and a half. I came in, well, actually I came in 2.5 hours early to go ahead and have these sharp aqueous problems kind of set up to make it go real fast today. And then I can use these for my next year's review and not have to do one. So I do have all the answers to everything too. I'm just double checking them. So my last one, I got 38, 0 degrees, 38 minutes. I'm gonna double check it. And 03.2. Okay, so deflection angles are just an accumulative. So the first one's always going to be the same, 3, 1, and I'm going to say this is 57 seconds because you'll see it's going to add up. And then we're going to add 2 degrees every time. So that would be 3 degrees, 31 minutes, 57 seconds. And that would be 5 degrees. So I'm adding these deflection increments. I'm adding them. So this particular one was 2 degrees. And then I'm going to add my last one. So I'm at 11 degrees, 31 minutes, 57 seconds. And then I'm going to add the 0 degrees, 03 minutes, 12 seconds. Oh, something wrong, because I should have I/2. And my I for this problem is 2420, so I should be at 1210. So let me see what I did wrong real quick. Well, I'm good up to that one, so I must have done that very last one wrong, because yeah, 11:31:57 is right. So I must have done the very last one wrong. So that's good to know. Everything else was good to that point. So let me go back. Or either I added wrong. 31.71 times 4 divided by 200. Okay, so that's right, so I just added wrong. And you're getting the drift. If my numbers don't add up to when I get to the top one and it's not half of I, then I know that I did something wrong. So like I'm going back through and checking what I did, but I think I know that I just had it wrong.
I got 38 minutes, 3 seconds, 0.12 seconds, I mean.
Oh, you at 38 there?
Yeah.
Oh.
For the top one instead of, actually, yeah, I got 38 instead of 312.
Oh, there it is. There's where I messed up. I put wrote it in wrong. It's 38:03. I wrote it over wrong. Okay.
38.3.
So 3. I'm gonna just do it to 3. I'm not even gonna do the 12 over here. That way it'll add up perfectly. I add that to it. That would be 12 degrees 10 minutes. Yay! That's half of I. So my I was 24:20, so half of I is 12:10. So it was the last one that I did wrong. All right, so I got to do total chords next. So I'm going to use equation 2413. I need to do total chords. So it's going to be 2R sine the deflection angle. So for the first one, this is going to be 62. So I'm going to write 62 here. You don't have to keep everything out on your test. You can do it in your calculator, that's fine. 14. Make sure that's my R. Yep, And then sine deflection angle. So the first one was that 1 degree, 31 minutes, and I think I had 57 seconds. Yep. And then I'm going to do 63. I'm going to go ahead and put them in first. So I will give you about a 3-second error. So if you're off like 3 seconds, you say you had 3 degrees, 31 minutes, and 54 seconds, I'll give you that much off, and maybe 3 100ths. So you don't have to be just because of rounding. So this is going to give me my total chords. And I'm going to start punching them in. I'm probably going to be, I'm going to do the first one at 62. .62. When I did it in the computer, it gave me 61. It was 616. So I'm going to go ahead and put what the others are. You're going to be, and because they use to the nearest decimals of a second, it may be off just 1 decimal place, like 126. For the next one, it should be 176.51. If you get 52, it's just because of rounding. So the 64 should be 276.19. 64 should be, is 64. 65 is 375.54. 66 should be 474.43. 67 should be 572.74. And the last one should be 603. I think it may be 70. It might be because ours is 78, which is our LC. I'm going to punch it in real quick. It'd be 603.77. All right, let's check, see if that matches my long chord. And it does. There's my long chord at the very top of this page. Lets me know that I'm good. So those numbers will go in right here. And that matched. Very last thing is we have to check the incremental chords, which is these. So we're going to use that same formula that we use for total chords. The only difference is that's 40. I think we got 40 here. And this is going to be your deflection increments, which is that 1 degree 31.56, which we should get the same thing. I think I had 131.57. Okay, that'll be the first one. And then the second one would be 2 times that's sine 2 degrees. Because those are all 2 degrees. So I'm putting this number in, then I'm going to do all of these, and then I'll do that end one, which is 0.3803. So I'm going to go ahead and tell you a quick way to get the 100-foot ones, those 2 degrees. Remember our D was 4 degrees, and we have that table that's on page 720. And if they're 4 degrees, if your degree of curve's 4 degrees, all of the true chords should be 99.98. So I wouldn't even have to really plug it in because that fell right on 4 degrees. But we're going to plug it in and see what comes out. So for the first one, it's probably the last one definitely is not going to change. The first one might change a tiny bit. I'm not sure, but I'm going to go ahead and plug them in. If in 100 feet it doesn't change but 3/100ths, that's nothing. That's 76.62, so did any change? I got 99.98. Yep, that's what they said it should be. I can tell you this one ain't gonna change either. The smaller the D, the less that it's going to change. If you have a D of like 10 degrees or 20, you might have, a bigger difference. I got 31.71. So I'd go back right over to my chart, and I would say I'd go through here and write 99.98. This was good. This was good. These I would just line through and do 99.98. And then that one's good, so I didn't have to do anything. So, we're done. Took me, what, maybe 30 minutes from start to end. Just know that I'm not going to give you one that long to do because you're not going to have that, I don't want to be that time consuming. All right, so this is a continuation. What's the sight distance? What sight distance is available if there's an obstruction on the radial line, meaning, we got our radius 20 feet over. Let's say you got something 20 feet over, and we want to find out, let me feel better. Let's look on page 746. This is our M, and they said that's 20 feet. And of course, we would know what our radius is. Our radius from that problem was what, 1432.40? For that last problem we just did, 1432.40. So C equals the square root of 8, which is a constant, times your m, 20 feet, times 1432.40. And that'll give me my sight distance. Square root. I got 478.73. That would be in feet. All right, I am going to save. I'm going to do a couple things. I'm going to do save and exit. And we'll go in and save it as a PDF too. You can see everything that I did today. Okay, good. All right, I'm going to go ahead and open the next one. So you'll have something similar to this, maybe not this hard, where I'll give you some of the components of the curve and then ask you to solve for what's missing. So this time it's a highway curve. They gave us I and they gave us E. We have to solve for D, R, and T. So gave us I. So I'm going to go to equation, right. What's a page number? Page 722. And I'm using, since they gave me E, that's 24.6. They gave me E is 73.6 equal to, we don't know R. And they gave us I, 28 degrees divided by the cosine of 28 degrees over 2. And then minus 1. I'm going to go ahead and solve for this side first. 28 degrees. I definitely got mine wrong. This is what I did wrong. Let me make sure I got my formula written right. E is equal to R. I bet I know what I did. So it's going to be, actually, we can say E is equal to that'll work out better for me. Oh, I know what I did wrong. I called that. That's exactly what I did wrong. That is a 1, not an I. That is 1, and I had it written as 1 there, but I was just thinking it was I. That's what I did wrong. So my E is there we go. Let's say 1 divided by the cosine of 28 divided by 2. And then minus 1 from that answer. I'm just going to leave it all in my calculator. That gives me 2,404.16. And I would be able to follow you if you rounded or didn't round. I'll be able to follow you. So that is my R. I'm going to go ahead and put a now I have R, and I want to solve for D. write it on the paper. Okay, at 14. Let me double check again.
You got 2404.157.
Yeah, that's what I got. That'd be 1/6. Just depends on how you carry the number out. Okay. I'm gonna go ahead and do it just to the 16. So for my D, it's 5729.58 divided by 2404.16. I need it in degrees, minutes, and seconds. So I got 2 degrees, 22 minutes, and 59.499 seconds. Okay, and now I have got I, so T equals R, which is 2004.16 times the tangent of I, and that's 28 degrees, divided by 2. We got 599.42. All right. So I'm gonna circle in my answers. And we're done. So you could have just a small problem where I give you 2 or 3 and then just ask you to solve for 1 or 2 other things. It could be something similar to in your book, maybe like 24-3 where they gave you R and then told you it was a highway curve or a railroad curve and they wanted you to solve for D. Or it could be just something like 24-4. D, they give you DC, I, and PI, and I might ask for just 3 things like T, E, or N. So it could be something like your problems that you worked in your simple curve test or the circular curve test, any of those. So if you need them and you want to print, I don't know if you can print your test out, but just something this simple. So I'm going to save this. See if it's saved. Yep, that's everything we did. All right, so that's it for horizontal curves. So what I'm going to do is I'm going to stop recording, take a break, and I'm going to log into the vertical curve one next.